then we'll move on to the next topic, that is about the properties of scalar product. Okay? In properties of scalar product, I come across something called as commutative property. I need not explain. It is simply directly A dot B is equal to B dot. Commutative property. Distributive property also, I'm sure you have studied from the second standard. Yes? A dot B plus C is equal to distributed, that is A dot B plus A dot C. This distribution is taking place. A is getting distributed to B as well as to the C. So that is distributive property. So which means commutative property holds good for scalar product, distributive property also holds good for scalar product. Okay? So then associative property we are not discussing about. I don't know how much good it holds or not. Maybe in some cases it holds good and some cases it does not. So that's why we are not going to put it as a property in scalar product. Okay? So we'll be moving on to the next one, that is A dot B. If A dot B, A vector and B vector are vectors, if lambda be any scalar, okay? So if dot product of two vectors, I can multiply that scalar to the first vector and then dot product it with the second vector, or I can first dot product of the two vectors and then multiply to the scalar, or I can multiply that scalar to the second vector and multiply with the first vector. You can follow any method you like. If I have to multiply a scalar to the dot product of two vectors, okay, so two dot product vectors, that scalar or a number can be multiplied with the first vector and then dot product with the second vector, or first I'll find out the dot product and then multiply it with the scalar, or I'll multiply that scalar to the second vector and then dot product it with the first vector. Any way it is possible. It is one and the same. That is what they mean. So you need not get confused. If they give a number, what should I do? Should I first multiply the vectors and then multiply the scalar, or individually I'll multiply it separately to the vectors and then multiply? So it is all the same. You can do it any way you want it. Okay. Then this particular note is a formula also, I can tell, or which is a topic which is going to be helpful for you in order to solve the problems or numericals. I can see that if A vector is equal to, this particular thing is already been done before, that assume that A vector is equal to A cap plus A1 I cap plus A2 J cap plus A3 K cap. B vector is B1 vector B1 I cap plus B2 J cap plus B3 K cap. So these two are the given vectors. Now dot product of this when the vector is given in its component form. Okay, dot product of the two vectors when it is given in the component form, I will frame a easier question, easier formula for that, or easier derivation, so that I can directly substitute in the answer to get the formula. Otherwise, here I can say that, okay, dot product, why can't I use this formula? They have not given you the angle between the two vectors, correct or not? So cos theta, you will be stuck there, you don't know what to do with the angle. So that's why whenever the component form is given, I am going to use this particular final derivation, what I do it. So I'll do it here. I'll give you all an idea how it is derived. I'll not derive the full thing, so that you can derive this thing full thing. And I want you all to derive this in detail once you look into this video. So first term is being distributed to the first three, with the second three like this distribution. Okay, then this one is being distributed to this. Okay, the third one is going to be distributed in the similar way. So I'll do it here. It is going to be I cap A1 I cap dot B1 I cap. Correct? This and this. This I can rewrite it also as A1 dot B1 into I cap dot J cap. Correct? Sorry, I cap dot I cap. These two are I and I. Correct? So same way, I will just write these things in detail for this one. I'll erase this. What I'll do is A1 dot B1. These are numbers. Don't forget, don't write it as vectors here now. These are the components or the numbers which is given in the question. So let it be as it is, and here it will be I cap dot I cap plus the next one, that is A1 dot B2 is I cap dot J cap. Correct or not? I cap dot J cap. Then here next one A1 dot B3 is I cap dot K cap. Here, yes, you can see I dot I is equal to 1. Yes, I dot j is equal to 0. I dot k is also equal to 0. Yes, so what do you see from this observation is only when that is I dot I, that particular number will remain, that is a1 b1 will remain. This all terms will multiply with 0 and they will be cancelled out. Which means if I continue with this particular thing, that this one and this one, if I multiply, it will become a2 dot b1 I cap j dot I cap, correct? This into this plus, what is that? a2 dot b2 j dot j cap plus a2 dot b3 j cap dot k cap. We can see this is 0, which goes, this remains since it is 1, this goes since it is 0. Yes, so this is what it remains here and this is what remains here. Then the last one, let me do this one into this, all the three terms. So here what it is happening, a3 into b1 k cap dot I cap, correct? Then plus a3 in dot b2 k cap dot j cap plus a3 dot b3 k cap dot k cap. Yeah, this is 0 gone, this is 0 gone, this is 1 which remains here. Okay, so which means all of these terms are gone. Okay, all of these terms are gone. Only thing remaining is a1 b1 plus a2 b2 plus a3. So this is my formula for in component form. Whenever they give it in component form, I will just multiply their components and add them up. Okay, that will be my final answer, which is a1 b1 plus a2 b2 plus a3 b3. That will be my, this obviously will be in numbers, correct? When I multiply two numbers, then add them, multiply, add them. So this will be a number itself, which means it is a real number. So a dot b is a real number and it is a scalar. Okay, so this is the formula which you will need in order to solve the problems. So please go through this. I want you all to derive it in neat form, detailedly. Okay, so that this derivation is not important, not there for the exam point of view, but this formula is a base for rest of the components present in my vectors topic. This formula is going to be the base for not only for the vectors but also the next chapter, 3-dimensional coordinate system. Okay, so I want you all to understand this thing clearly. Okay, why I am not using this here? Because angle is not given, that's why I am going to use this method whenever the component form is given. Understand clearly. Okay, so moving on to the next last topic of explanation, that is projection of a vector on a line. Okay, if a random vector is there and making an angle of theta with respect to a straight line, this is not a vector. Okay, let me not imagine this as a vector. Let me imagine that this is simply a straight line. Okay, simply a straight line AC. AC is a straight line, and AB is the line which carries the vector along with that. AB is the line which carries a vector, A vector along with that. Okay, this is like this. This is a straight line randomly, and this is a vector. Okay, now this vector, what effect it is having on this line? Okay, what is the effect of this vector on this line, or the projection of this going above vector on this line is nothing but I will just project the B point to C point directly straight like that, and I will find out what is this AC. Okay, AC, let me imagine that this AC is a vector which is the effect of A vector. Okay, AC vector or B vector, I will name it as. So which means projection of A on B vector is equal to A vector dot B cap. Okay, projection I am talking about. I am not talking about dot product now. Projection of a vector on a line or another vector is simply nothing but the dot product of the vector and the unit vector along the straight line or unit vector along the other vector. Okay, so which is, it means A on B is A vector dot B cap, or B cap, you know what it is, that vector divided by magnitude, you know, unit vector formula. B cap is nothing but B vector divided by magnitude of B vector. So this can also be written in this form, that A vector in dot B vector by B magnitude of B, which means I can also write it in another way, that numerator is multiplied A dot B vector divided by magnitude of B vector. So this is the formula when to find out the projection of A vector on B vector. The second formula, which will clear out the first confusion whatever we have, that is, what is the projection of B vector on A vector? Okay, what is the projection of this vector on this vector? Okay, this is like this. What is the projection of this horizontal vector on this side? The same imagination I can do. B vector on A is nothing but B vector dot A cap. On whose the projection is falling, that one's unit vector I need to dot product it with the vector. Okay, so it is B vector dot A cap. A cap is nothing but magnitude of, A vector divided by magnitude of A vector, which indirectly tells A dot B divided by magnitude of A. So you can see the numerator remains the same for both of those, and based on what it is projected, the denominator will change. If the vector is projected on B vector, then the magnitude of B will be in the denominator. If it is projected on A vector, then the magnitude of A will be on the denominator. A dot B and A dot B is going to be the same thing on the numerator of projection of a vector. Okay, it is same as writing projection of a vector on a vector again, or projection of a vector on a line. Okay, so this is the detailed explanation for the next exercise which you are going to solve for. Okay, so please pause the video, clearly note everything down, and any questions or any silly doubts you have, please let me know. We will clear the things and then we'll move on to the exercise numericals. Okay, thank you.